In this lesson, we're going to multiply complex numbers, and we need to remember several things. Be prepared to use the distributive property, be prepared to use FOIL, and definitely remember this, that I squared can be replaced with the number -1. It is very, very important that you remember this. Let's take a look at number 1. It says to multiply, and what form of multiplication am I going to use? It looks like I'm going to use the distributive property. 5i times 8 gives me 40i. 5i times -4i, and you probably feel like you're treating the I like it's an X, and you are, -20i squared. Now this is what I'm going to do every time I encounter an I squared. I know that I squared is -1, so it's -20 times -1. This is the easy thing to do. Mark off the I squared and change the sign of the 20. That has the effect of having multiplied it by -1. So what do I have? I have 40i plus 20. And since complex numbers are written in the form a plus bi, it is customary to write the real part first and the imaginary part second. So it is customary to see that as 20 plus 40i. All right, let's look at our next one. Distributive property again. -5i times 6i gives me -30i squared, because I had an I times an I. Then -5i times -9 gives me +45i. I squared. I remember, I squared is actually -1. Multiply this by -1 and it becomes +30. That means that this is 30 plus 45i. Let's look at number 3. This time I have 2 terms times 2 terms, and I need to do this with the FOIL process. So I'll go ahead and write it out this time. First, I have 2 times 3, which is 6. Outer, I have 2 times I, which is 2i. Inner, I have 3i times 3, which is 9i. Last, I have 3i times I, which gives me 3i squared. What do I do when I see an I squared? Get rid of the I squared and replace it with the factor of -1, which causes a sign change. All right, what do I have from all of this? I have 6 plus 2i plus 9i minus, now, rational real 3. Combine the real parts. 3 and -3 and 6 is 3. 2i and 9i is 11i. 3 plus 11i. Let's look at the next one. I have 35 minus 5i times 7 plus I. I need to use FOIL again. I'm going to have 35 times 7. I think I'll grab my calculator, which is 245. The outer product is 35 times I, so it is 35i. The inner product is -5i times 7, which gives me, instead of plus, minus 35i, that's my inner. My last is negative 5i times I, so it's negative 5i squared. First, outer, inner, last. The last involves an I squared, so I get my red ink, get rid of that, changes it to plus 5. So what do I have? I have the real parts of 245 plus 5, which is 250. And, oh, the I squareds, the I's are opposites, so those cancel out. So I got a real product. But remember, a real number is just a type of complex number where the imaginary part is 0. I'm having a little trouble. There we go. All right, next I'm going to talk about 8 plus 4i times 8 minus 4i. Does that ring a bell? Remember the word conjugate. Those are conjugates, a sum and a difference of the same two. Let's see what happens when you multiply complex conjugates. Product of the first, 8 times 8 is 64. The outer, 8 times negative 4i is negative 32i. The inner, 4i times 8 is plus 32i. The last, positive 4i times negative 4i is negative 16i squared. Okay, I squared, gone, replaced with a factor of negative 1, which causes a sign change. I have 64 plus 16 gives me 80. Sorry. I have positive 32i and negative 32i, and those cancel, and I get 80. Now, you can get a real answer without the two being conjugates. But if they are conjugates, you absolutely are guaranteed to get a real product. That's going to come back to visit us in our next lesson. The product of complex conjugates will no longer have an I in it. All right, last one. We're asked to square a complex number. So if I have 2 plus 9i and multiply it by 2 plus 9i, the product of the first, 2 times 2 is 4. The outer product, 2 times 9i, is 18i. That was messy. Rewrite that. The inner product is another 18i, not opposites, they're the same. And the product of the last is 81i squared. I squared changes that now to negative 81. For the real part, I have 4 minus 81 is negative 77. For the imaginary part, I have plus 36i. And there is the value when I squared that. So hopefully you feel comfortable multiplying complex numbers. And notice this one case, it was the only one we had like this. When you multiply complex conjugates, you are guaranteed to get a real product. Okay, you work on some homework.